Hello everyone, welcome to all of you. So guys, please confirm first of all audio and video is clear or not. So first of all, sorry because of the some technical issue I was not able to start my streaming, but now it is okay. So I hope audio video are clear from my side. Please confirm bachcho. Please confirm. Yes. So here, as we know very well, in this session also we are going to continue the GATE 2023 questions of engineering mathematics. In the last session we had a discussion about the electronics branch questions. Okay, one question was there left, so we will start from this question and the weightage of this question is 2 mark. So let's start with the question. So please confirm first of all, audio video is clear or not? Right. Okay. So let's deal with this question. This question is from integral calculus. If I will talk about the question. Okay. All right. So if I will talk about the question, this question is from for the EC branch 2 mark question, and this question we can say as an integral calculus, or better I will say that this question is from the vector calculus. Specifically this question we can solve. So the value of the integral double integration xy dx dy over the region R given in the figure is, we need to find out the value up to the nearest integer value. Round off, we need to round off up to the nearest integer. So let's solve here. The question is mentioned. Okay, in this one we can see very easily it will become, so parallel to x-axis we are having, because here it is already divided na, so we can divide this one and this is again parallel to x-axis. Okay, so what we can do, dear students, we can approach this, we can just divide this given region into the two parts, the upper one and the lower one. If I will go with the upper one, I can see, okay, this area I will find out and I will go with the double because all are same here. So this is x plus 2 to minus x plus 2 minus x and x. So it will become very easy to solve. So let's approach it. What I will do, I will write down here my required area. So this time I want to take a strip parallel to x-axis for making it easy. So what I will do, I will just solve like this one. So my area for the upper one, when I am taking the strip parallel to x-axis, my limit is x value of x is 0 to 2. You can write down directly 0 to 1 only, and here also 0 to 1. So I will write down value of x is 0 to 1, and when I will go with y, the limit of y, we can see the limit of y, we are having two limits for y, which is or y is or x is equals to minus y, because I am taking here x-axis now. So this is for y is equals to 0 to y is equals to 1, and x is equals to minus y to x is equals to plus y. This will be very easy. X is equals to, I can see now, x is equals to minus y to x is equals to plus y, and on y-axis it is going from this 0 to this 1. On y-axis it is going from this 0 to this 1, and if you want to take the strip, I will show this one here where with this purple color you can see this is the strip here we are having, and this is going from y is equal or x is equals to minus y to x is equals to y, x is equals to minus y to y, and for y-axis my limit will be y is equals to 0 to y is equals to 1 directly. So I will solve it, y is equals to 0 to y is equals to 1, x is equals to minus y to y, and the value of the function already given to me, so I am taking x here, so this will be x and y. So I will take x here and now I will solve it. Okay, plus this is the first one. If you want to take the upper one, then it will be from 1 to 2. So here only you can take, so that we will find out the required area within the 2 step. That's why I told you, rather using here the strip parallel to y-axis, we should directly go with parallel to x-axis here. So if I will go here for this this upper one, so I am having the value of I need to find out the value of x, so which will be y minus 2, and from here x will be, if you will go there, so it will be, or if you want to write down like this, so your value of x will be, if we will go there, so and it will be here, so it will be 2 minus y. Okay, so when you will write down, this is y minus 2 to 2 minus y, so value of x is y minus 2 to 2 minus y, and my y-axis is lying between 1 to 2. So I will write down y is existing between 1 to 2. and now this is again dx and dy. Okay, so parallel to x axis once we will solve, and then parallel to y axis we will solve, and we will get the result. This is 0. So surely I will write down this one. So when I will solve this parallel to x axis, my result is, it will be as it is, y is equals to 0 to 1. Dear students, y we can write down outside. When I will go with this one, so this will be x square by 2. X square by 2, we are having the limit minus y to y, and this is dy. Okay, and here when I will go with this one, so this is y is equals to 1 to 2 we are having, and here I can take again y, and when I will solve this one, this is also x square by 2. My limit is opposite, y minus 2 and 2 minus y. Okay, and here the y is already done, x is already done, so y is remaining. So when you will solve, we can see this is y square, and when you will solve this one and when you will put the value of x and y both, it will become 0 in both the cases bachcho. So it is nothing but 0, and this will also become 0. So ultimately my final answer will be what? 0. I can solve directly that my answer is equals to 0. So very easily we can approach the question. The result is having 0. Alright. Okay. So in this manner we can solve the question. So this is a good question, and we need to approach every time these type of questions taking the strip. So strip method is very easy and very effectively whenever you want to use. Alright guys. Now let's come to the next question. Okay. Yeah, this is the question. So you guys will try this question first of all, then I will go with the solution. We will have a detailed discussion on the solution also. So you should try. This is a very easy question, although the vectors, w vector is given to you, the vector normal to the plane. Normal to the plane means gradient they are asking. So defined by w transpose x is 1. So the normal vector you need to find out. Everybody just go for it. Just go for it. Prakhar is saying double integration results in area, then why this y dx dy results in volume? No, this not results in the volume. This is area only. This is area only, beta. Prakhar, it is not volume, it is area only. Yes, bachcho, let's approach it. So what is the result according to you? Let's approach it. So the question, we are having a very good question from the, let's approach it again. So we are having a very simple question from the, again, linear algebra. What is given to you? The question is of 1 mark from EE for a given vector w 1 2 3 transpose the vector normal to the, no, this is not actually, we can see this is the mixture of linear algebra and calculus, because here the vector is given to you, okay, if you will see the normal questions from the calculus na, in the gradient, in the vector calculus, so we are having the question itself in the form of the vector. If in one shot you will see the question very carefully, you can see this line which is talking about the vector, this is from the linear algebra. Again this line is also from the linear algebra. So this question you think that from the linear algebra, but this is the mixture of algebra and calculus both. So let's approach the question again. So if I will go with the question, let me read out the question for you, dear students. For a given vector w, so vector w is given to you, which is 1, 2 and 3. If I will talk about the vector normal, so normal to the vector is nothing but gradient. So you need to find out the gradient of any vector, whatever the vector you are saying, if it is phi, f, whatever it is. Okay, so gradient of phi you need to find out, and which is defined by the w transpose x is 1. So for finding gradient, what is my requirement? My requirement is function only. So I cannot see here in the function. So the function is given in the form of the matrix. From this w transpose into x, I need to find out the function, and then I will go for the normal to the surface or vector normal. So then I will go for the gradient. So let's approach it, bacho. Yeah, very good. Akash is there with the answer. Let's have a discussion. So what I will do, I will write down whatever is given w transpose x is 1. So if this is w, you can write down your w transpose. So w transpose will be 1, 2 and 3 only, right? If your w is this one, so w you can write down, this is the w. You are asking about w transpose now, so this will be the w transpose. So I will write down my w transpose, or if the w is given to me 1, 2, 3 transpose, so my w transpose will be 1, 2 and 3. If I want to go with this one, so this is 1, 2 and 3, and x we are having, we don't know about the x, so x you can write down as 1 x y z only na bacho. So what you will go with 1, 2 and 3, and here x is x, y, z. X is nothing but variables, and this is equals to 1. When you will multiply, this is x plus 2y plus 3z is equals to 1. We are having this as in this is given to me function. Maybe here it is not w. Okay, this is not transpose. It should not be transpose here, because if it is transpose, then the question will be wrong. Yeah, okay. So we are having this, so they are writing the value of the function, it's okay. So they are writing the value of the function. W is given to you in the form of this one, so W transpose. So I will write down it directly. So let me write down here with this thought that the W transpose is, wait a minute, my charger need to connect. Yeah, so for this question, W is, we can write down here only that it is given to us, the W value is 1, 2, 3 transpose. So my W transpose will be 1, 2, okay, and this you can write down as 1, 2, 3. So my W transpose will be 1, 2, 3 transpose, which is equals to 1, 2 and 3. Okay, if I will go with this one, W transpose into X is equals to 1. So W transpose is 1, 2, 3, and your X will be X, Y, Z, and this is equals to 1. When you will multiply first row with this one, so this is X, second row with this second column, this is 2Y, third row with this third column, this is 3Z is equals to 1. So X plus 2Y plus 3Z is equals to 1 we are having. Okay, X plus 2y plus 3z is equals to 1 we are having. What we need to do, we need to find out here the vector normal. So vector normal means we need to go for the gradient. So this you need to write down as in the form of the vector. So I am considering this, let us assume this as a vector function, or this as in function phi. Okay, this is a scalar function phi. For that I need to find out the vector normal means the gradient. So gradient of phi will be I del phi by del x plus j del phi by del y plus k del phi by del z. So when you will solve, so for this one if I will solve, so this is 1 only, so 1 means I Okay, directly we can write down now. Or if you want to write down this in the form of the function now, so we can write down as I plus 2j plus 3k. Okay, so then you can go directly with this one, or directly the gradient phi. So I want to write down gradient in the form of the specifically. So I am writing 1I plus, when I will go with this one, so this will be 2j. When I will go with this one, this will be 3k. So step by step I am approaching. So this is my gradient of phi. So gradient of phi is called the normal to the surface only, or the vector normal. So this is equals to I plus 2j plus 3k. But the question is asking again in the form of the vector or in the form of the matrix. So in the form of the vector it is given, they are asking about the matrix. So the result will be in the form of the matrix. You can write down this is 1 2 3. You can write down this as in 1 2 3 transpose. So what should be your answer? Your answer should be option D for Delhi. 1 2 3 transpose, because if you will write down in the form of the vector now, so it will be 1 2 and 3. Either this one or this one will be your answer. Right? Very easily we can approach it, bacho. Yes. Now let's go for the next question. This question is again a good question from the EE and 1 mark question. The question is about the differential equation, but please read the question very carefully. Can we approach it directly? Do we are having here direct form of differential equation, or we need to use any other method? So in the following differential equation, numerically obtained value. So this is the numerical solution of differential equation, means this question we can solve by the numerical methods. Okay, value of yt at t is equals to 1, t is equals to 1, dy by dt equals to e to the power minus at by 2 plus at, where a or alpha is equals to 0.01 and y0 is equals to 0. So the initial roots are given to us in this question. We can solve the question by any of the numerical method. So what is the method for solving differential equation in the numerical? And then we will approach it. Yes, bachcho. All right. Let's approach this question. So this question is from the numerical methods. If I will come to the question, this is a 1 mark question. So the following differential equation, the numerically obtained value of yt at t is equals to 1 is what, and when the equation is given to you. So we can write down the equation. First of all, the given equation is dy by dt is equals to e to the power minus alpha t or at divided by 2 plus alpha t. Okay, and here the value of alpha is 0.01 and initial root y0 is equals to 0. These two things are also given to us. All right, so is this alpha? Yeah, we can take this as an alpha only. So if I will take this as an alpha, so I can solve. So first of all, I need to find out the numerical solution. I can see here we cannot go with directly any numerical means this is not any different any form of the differential equation. So better I will solve this question with the form of the with the help of the Taylor series. So I will use here the Taylor series form. So by Taylor series we will solve this question. How? Let's have an approach. So before approaching that, we need to know what is the formula for the Taylor series. So yx is equals to why, if we will start from the 0 initial root, so this is because it is asking about x is equals to 0 na, so I am writing here directly for x is equals to 0. So y0 plus x, y dash 0, y dash 0 means first order derivative, plus x square by 2 factorial y double dash 0, and so on. I need to go with this one. Okay, so what I will do, I will go with yx is equals to y0. Y0 is your initial root and which is given to you already 0. So you will write down here the value of 0, and this y dash 0 means here in this function we will put the value as t is equals to 0. So when I will put here, so let me write down x, and in this one I will put the value as t is equals to 0. So this is e to the power minus alpha 0 divided by 2 plus alpha into 0. Okay, plus x square by 2 factorial, and if you want to go for the more further, so what you need to do, you need to differentiate the given one, and when you will solve, this will be minus 3a by 4. So when means 3 alpha by 4, so we can write down directly here, this will be minus 3 alpha by 4, double derivative. Okay, so minus 3 alpha by 4, because here we are having this value, so if I will put, this will be 0 plus x I am having, though this will be 1, so I am having x by 2 from the first one. Okay, if I will go with the second one, so this will be 3 by 8 we are having, and this is alpha, and we are having alpha also, and x square. So if I will go with the value of the alpha, here I need to put the value now, I need to find out the value at alpha is equals to 0.01. So I will put here the value of the function. First of all, we will put here x is equals to 1, because it is asking na at t is equals to 1. So we will put here x or t is equals to 1. So at t is equals to 1, the value will be 0.5. You can write down the value. T is equals to 1, the value of the function is 1 na. So 0.5 minus, when you will solve this one, this is 0.00375. 0.00, only 20, 0.00375. Okay, and when I will solve this one, so directly I can write down the value which is 0.5 minus 0.00375, 0.496. So 0.496, which you can write down up to the decimal places, 2 decimal places. So you can write down the result as 0.50 also. So we can solve, or we can write down the result as 0.50. No, 0.74, no, it's not 0.74. It's not 0.74. When I will go with the differentiation, now look at here, this function is given to you, this is the first order. If you will go with this one, you need to go with one more differentiation. After this one, minus 3 alpha by 4 we are having here, we are having the value of x. X is actually nothing but t. So what you can do now, here you can put the t, at the place of x you can put the t. So this will be t, this will be in the form of t only. So we will have the equation in the form of t. So this is my general equation, but here in the question we are having a differential equation in the form of alpha and t both. So I will put here the t. So this is my equation yt, and as it is given to you, the value of t is 1. At t is equals to 1, we are having this root alpha is 0.01. So I will put value of t is 1 and alpha is 0.01. So when I will put here, I will get the result 0.50. Yes, I will get the result 0.50. Okay, so like this we can solve the question. All right, now let's come to the next question. Now this is the very good question from the probability. So let's read the question. You can try the question and then we will have a detailed discussion. The expected number of trials for first occurrence of a head in a biased coin. So the coin which is given to you is a biased coin, okay, is known to be 4. So the probability, or it is clearly mentioned that the expected number of trials we need to find out, Okay, expected number of trials for the first occurrence of a head in a biased coin. So when you will throw a biased coin, the first time you will you will get head as on the fourth number. Okay, so the probability of first occurrence of a head in the second trial, the probability, okay, when you will get the means the very first time head on the second time, then what is the result? So a good question, surely a very good question we are having, and this is again a numerical answer type question. So with the basic expectation method we can solve the question. Let's approach this question. This question is from the probability and statistics. So let's go with the question. The question is talking about the expected number of trials for the first occurrence of a head in a biased coin. So the coin which is given to us is a biased coin, okay, is to be 4, known to be 4. The probability of first occurrence of a head, okay, we need to find out head at the very first, means when we will get the first head, that the number will be, the toss will be second or the trial will be second. Here we need to find out the probability for that one. Alright, so we can solve this very easily. Now first of all, what is given to you here? It is given to you expected number. Now expected number means the expected value. So expected value when you get head in the biased coin is 4. Okay, now when I will come to this one, I can use here the simple x and the probability. So I will go here with the very simple approach that my x is suppose when I will throw one time head, okay, when I will, means the number of trial is 1. So when I will throw one time, in this case I will get head or tail, right? Anything is possible here. So okay, before that we can write down, let we are denoting head with the probability p. Okay, I will denote head with the p, and tail, if getting head the probability is p, then getting tail the probability will be what? 1 minus p na. If getting head my probability is p, then getting tail my probability will be 1 minus p. So if I want to make it easy, so I will go here with this table. I will make a simple table. Okay, so here when I will write down x and pi, so we can go with x and pi. Here we can start, suppose my number of trial is 1, so in this case when we just throw the coin or when we just toss the coin, we are getting head, because it is asking about head only na. So I am considering all the conditions ki what should be my result. So when I will just throw my coin very first time, I will have the head, so the probability is p. Suppose I will throw my coin 2 times, okay, and in this case I will have the head. So in this case I will have the head. It means in the first case you are asking about the head on the second trial. So when we are throwing, so head on the second trial, so on the first trial you are having tail, on the second trial you are having head. So this is for getting tail, the probability is 1 minus p. Getting head, the probability is p. Like this I can proceed. Okay, I am talking about in general. So if I will go with the third one means suppose I am getting head in the third trial. So this will be tail and head, like this only na. So it will be 1 minus p 2 time, and then head it is p. So and so on we can go with this one. So we are using this simple concept and we can solve the question. So yeah, when I will go with this one, I can see, and it is given to me that the expected value means expected value summation of xi pi, which is e equals to 4. So we will use this one, we will solve, we will use these things, and equals to 4. So I will write down here x is this one, p is this one. So this is 1 into p, plus for the second one this is 2 into p into 1 minus p. Next is 3 into, we are having 3 into p into 1 minus p whole square, and so on, and this is equals to what, 4. What we can do, we can take directly p common from this series. It will be 1 plus 2 into 1 minus p plus 3 into 1 minus p whole square, and so on. It will be going on, and it is equals to 4. I can see here this is nothing but a simple series we can use. This is just looks like 1 plus 2x plus 3x square plus 4x square. So all are positive. So in this case my expansion will be p, and here it will be, this is nothing but 1 minus p power minus 2. So means here we are having already 1. So this is nothing but the expansion of 1 minus p, or let me write down again with the different color. So this is p we are having already. This is 1 minus of p. So this is 1 minus x power minus 2 na. So minus 2 here we are having. So when I will just go with this series from here to here, this is minus 2. So 1 minus p to the power minus 2, and the result is already equals to 4. So when you will open it, you can solve it. So this is p, when you will open, this is 1 minus 1 plus p to the power minus 2 is equals to 4. 1 and 1 will be gone from here, and when we will open this one, we can see we are having p. We can see from here we are having p, the value of p directly, or p into p power minus 2 is equals to 4, or you can write down this is 1 by p square into p. So p will be gone, is equals to 4. So you can write down the value of p is nothing but 1 by 4. Value of p means the probability of getting head is 1 by 4. So if probability of getting head is 1 by 4, you are asking about, okay, what I did, because here not the individual probability is not given to me. And one more thing, here it is mentioned that the coin which we tossed is a biased coin. So I cannot take here directly the probability of getting head is 1 by 2, probability of getting tail is 1 by 2. That's why I need to take it as p or 1 minus p, and then we can solve very easily. So now you are asking about the required probability is getting first head on the second trial. So getting first head on the second trial is this case th, like this case you are asking now. So your required probability now is what, dear students? This is 1 minus p into p. So this is 1 minus 1 by 4 into p is 1 by 4. So this is 3 by 4 into 1 by 4, which is 3 by 16. As I can see, this question is from a numerical answer type question. So when I will solve, this is 0.2. 0.1875. So here you can write down the result as 0.188 or 0.1875. This will be my final answer in this case. This will be the final answer in this case. So very easily we can solve and we can get the result. So this is definitely a deserving question of 2 marks. Very good question, because in this question we are having a twist. The twist is that the given coin is not a simple coin or not a fair coin. The given coin is a biased coin, and whenever we are having biased coin, we cannot write down directly the probability of for head and tail is 1/2, right? Yeah, so that's why we need to be, no, the result is not 0.25. Akansha, the question is not asking me about the probability for head. Okay, the question is asking that head in the second trial. So head in the second trial is this case. So I am using expected value because this is given to me an expected number. Expected number means the expected value, means the mean, means the weighted average. So it is given to me, that's why we are using this concept to solve the question. Alright, now I hope this is clear to everyone. Okay, now let's go with this question. This is again a good question from the EE branch 2 mark question. The closed curve shown in the figure is described by r is equals to 1 plus cos theta, where r is root of x square plus y square, x is r cos theta, y is r sin theta. The magnitude of the line integral of the vector field is given to you. F is minus y I cap plus x j cap around the closed curve. This closed curve we need to find out the value. Let's approach it, everyone. A very good question we are having again. A very good question we are having. So this, the figure is looks like the cardioid, although we can use here the theorem, Green's theorem we can use, but still you can try. A good question we are having. Let's approach it. The pen is all right. Let's go for it. So we can see that this question is from the vector calculus and the weightage of the question is 2 mark. So question is talking about closed curve shown in the figure. So the figure is cardioid only, described by r is equals to 1 plus cos theta, where r is nothing but the square root of x square y square. X and r is r cos theta, y r sin theta. The magnitude of the line integral of the vector field around the closed curve. We need to find out the magnitude of the line integral. Okay, so I will use here the Green's theorem. If I want to use the Green's theorem, we know very well that Green's theorems convert line integral into the double integral or vice versa with the help of the partial differentiation. So we can write down here directly by Green's theorem. by Green's theorem, if I want to write down any question which is given to me in the form of the line integral, so suppose my question in the form of p dx plus q dy. If my question is in this form p dx plus q dy, if I want to use here the Green's theorem, then according to this Green theorem we can convert this line integral into the double integration. It will become del q by del x minus del p by del y, and this is dx dy. Okay, sorry, yeah, and this is dx dy. So what I can see, as I cannot see here the value of the function, so what is given to you, the curve. So the given curve is, you can write down here only, even before that you can write down that the given curve r is equals to 1 plus cos theta we are having. Means this is the curve which is given to me. This is the curve which is given to me. I will go with this curve only, FDR. Okay. Acha, one more thing from this one. Let me write down so it will give you the clarity that FDR. Sorry. So when I will go with this one, FDR, we are having the minus yi plus xj. So you can write down this FDR in the form of the integration or integration only. So this will become minus y dx plus x dy. Okay. Alright, so these things are given to us and we will use only these things which is given to us. So I will write down my question as, so I can go with this as an f1 dx plus f2 dy, okay, as equals to del f2 by del x minus del f1 by del y and dx dy. So when you will see here, this is my f1 first function and this is f2. So value of f1 is minus y. When I will put here the value, this is minus y by y. So you will get the result nothing but minus y. When I will just differentiate, this will be minus minus, or you can write down here minus 1 only. So when I will just differentiate this function with respect to y, so I will have del f1 by del y. So this is minus 1 only with respect to y. When I will go with this del f2 by del x with respect to x, right? So this function x, so this will be 1 minus 1 we are having, and this is nothing but dx dy. So you can solve this one as the required area, or the required I is equals to double integration 1 plus 1 is 2 dx dy. So dx dy 2 you can take outside, and this is nothing but the closed curve region which is dx and dy. So here you can use directly that the area of the region bounded by the given closed curve. So I will write down here, this is nothing but the double integration is nothing but area bacho. So this is twice of area of the region bounded by the given curve. Area of the region bounded by given curve. Okay. So whatever the curve is given to you, if you will no, the result is 0.6.28. I don't think, this is around 9 point something we are having. Let's have a check. So when I will go with this one, so I can put the value here. So this is nothing but twice we are having, and the area of cardioid is 1 by 2 r square. If you want to use this one directly, area of the given cardioid is 1 by 2 r square. So I will go with 1 by 2 r square, where theta is lying between 0 to 2 pi r square, and d theta I will go directly. Okay, and here 2 and 2 will be gone. So the required area is equals to theta equals to 0 to 2 pi r square, and d theta we are having. Now we can put the value of r as 1 plus cos theta, whatever is given to us. So let's put here the value 1 plus cos theta whole square d theta. So now what I need to do, I will just open it and I will integrate. So this is 1 plus 2 cos theta plus cos square theta, and here we are having d theta. Now let's integrate 1 by 1 from 0 to 2 pi. So when I will go here for with respect to 1, when I will go with 0 to 2 pi, so integration will be theta only, limit is 0 to 2 pi. For this one you can write down twice 0 to 2 pi cos theta d theta, plus this one you can write down 0 to 2 pi cos square theta and d theta. Okay, so this will become 2 pi directly. Here what I can do now, I am having cos theta, so I want to make it easy. So what I will do, I will just write down this. Right now this is the as it is step. So this 0 to 2a, I hope you guys remember about this property of definite integral 0 to 2a whenever we are having any function fx dx na, which we can write down twice 0 to a fx dx also, or even we can write down this if you want to half, you want to make it more half na. So you can go with this a by 2. So this will be 2 into 2, 4, 0 to a by 2 fx dx. Like this we can approach the question. Okay, so like this we can approach. So that's why I want to use the same technique here. So it will be only half, 0 to pi by 2, 0 to pi I want here. So this will be 2 into 2, 4, and this angle will become 0 to pi cos theta, because when I will approach the limit it will be easy to apply. That's why we are breaking the limits here. And here I want to apply from 0 to pi by 2, because for 0 to pi by 2 directly we are having the integration, we can solve it very easily again. So that's why I want to break it as a 4, and this will be 0 to pi by 2 cos square theta and d theta. Okay, so now when I will use this one, so this will be 2 pi, and here we are having already 4, and when you will solve this one, this is the cos, you can put the value or directly. So this will become 0 only, because cos, we are having here sin pi and sin 0 is 0 only. So this will become 0, and when you will solve this one na, so for that we are having a formula 0 to pi by 2 cos to the power nx dx, which is always is equals to n. Okay, if you remember all the terms we are having here as n minus 1, n minus 2 divided by n minus 3, like this. So you can go with all the odd terms, n minus 1, n minus 3, n minus 5 and so on, divided by n minus 2, n minus 4 and so on. Okay, and if your n is even number, then you will multiply with pi by 2 also here. So this is the formula for cos to the power n or sin to the power n when we are having integration 0 to pi by 2. So here I can break, this will become 0, and if I will go with this one, so this will be 4 into pi by 2 as here, and n is 1 only, so n is 2 only, so this is 2 minus 1 divided by 2. Okay, so you can solve this, 2 and 2, 4 will be gone. Here we are having pi only. So this is 2 pi plus 0 plus pi. So you can write down this as a keynote. If you don't know, you can write down this as a keynote. This is the formula. So this will be 3 pi. Okay, 3 pi, as I need to find out the value, so I will put the value of pi as 3.14. So this will be 3 into 3.14. So I am having result around 9. So this will be 9.412. This will be 9.442, not 412. So my result is around 9.42. You can check the calculator also. So this will be around 9.42, as I hope this is asking about decimal na. Round off to the 2 decimal places. So we can very easily write down round off up to the 2 decimal places. 9.42. Okay, guys. Yes, so I hope this is clear. So these type of questions, whatever we approached, are very easy to approach, but again we need because the weightage of the question is 2 marks, so we need to do here so many efforts. Directly we cannot approach the Green's theorem, because the given function is, earlier it was in the form of the function x f1 f2, but here we are having the closed curve which it is talking about. So the closed curve is a cardioid, so we need to use directly here the formula for the area of cardioid, and then we can proceed accordingly the given figure. Okay, but so yes Akansha, this is 9.42. So we will get the result like this only. Alright, so we are having more questions, but now I need to just sum up the session, because we okay, let's approach the last question. This is from the EE. Then in the next session we will start from the civil. So let's approach this one more question. Okay, so the question is, a quadratic function of 2 variables is given to you. So this is a function two variables. So maybe here we need to go with the maxima minima. Let's read the question, then I will tell you. So we are having a two variable function f of x1 x2 x1 square plus 2x2 square plus 3x1 plus 3x2 plus x1 x2 plus 1. So the magnitude of the maximum rate of change of the function, magnitude of the maximum rate of the change, please be careful with this line, this is very important, and the point is given to you. I am sure everyone can approach this question because this is very easy question. Every student can approach this question very easily. Yes, just go for it bacho. Very easily we can approach this question because this question is directly from the vector calculus again, and when it is mentioned now maximum rate of change of the function, you will get the hint that what you need to do. You need to find out here actually nothing but the maximum directional derivative. Maximum directional derivative, nothing else. Or the magnitude of the gradient of the given function. You guys will try, then I will tell you how to approach the result. Yeah, this is about the gradient. Very good, Akansha. This is about the gradient. But the magnitude of the gradient means the maximum value, which we used to call as a directional derivative. Maximum value of the gradient means the greatest value of the gradient means the maximum directional derivative. We need to find out here, or the magnitude. Or you can see the magnitude of your gradient we need to find out. Go for it, bacho. And in the next session, we will start from the Civil 2023 question. Civil Mechanical we are having, and IN CS also we are having. Civil Mechanical, IN and CS we will start in the next session. Okay. Let's go to the question. So I can see the question is very simple, very easy question. Let's read the question again. So this question is from the vector calculus. The question is talking about a quadratic function of the two variables. So this is a function of two variables given to you. The magnitude of the maximum rate of change. Maximum rate of change means the gradient. So we need to find out the magnitude of the gradient in this case at the given point 1, 1. So let's approach it. So we can write down the given function f is x1 square plus x2 square plus this is 2x2 square plus 3x1 3x2 plus x1 x2, and we are having plus 1 also. So this is the function which is given to us. Okay, x1 x2 plus 1. So I will go with the magnitude. Magnitude means first of all I will find out the gradient. Gradient means I del f by del x plus j del f by del y. Here we are having x1 x2, so I will write down x2 plus k del f by del x3. We don't have x3, so we will only find out for x1 and x2 only. So I will go for the gradient of f, and with respect to x1 if I will solve, so this will be 2x1 plus this will be 3 and plus this will be x2. When I will solve with respect to x2, so this will be 2 2 ja 4 x2 plus this is 3 and plus this is x1. So we are having these values at as the point is also given to you. When I will come to the point, my point is 1 1. So I will find out the value of the gradient at the point 1 1. So when you will approach here 1 1, this is 2 plus 3 plus 1. So 6 we are having 6i plus 4 plus 3 7 plus 1 8. So this is 8j. 6i plus 8j we are having at the point you want magnitude. So the magnitude will be square root of 6 square plus 8 square. 6 square is 36, 8 square is 64. The total is 100. You can write down the magnitude, means the square root is nothing but 10. So your magnitude of the gradient means the magnitude of maximum changes here is nothing but maximum rate of change is nothing but 10 here. This was a numerical answer type question and the weightage of the question was 2 mark. So definitely I hope this is clear to everyone. Yeah, Akansha, the result is 10. Shabash, very good. So the result is 10. We can see this is very easily we can approach it. Okay, so that's all from this lecture. We are having more questions to go, but as we are having time limitation also, so in the next session I will start from the civil. Okay, civil we are having 2 sessions, forenoon and afternoon. Then we will go for the mechanical also, we will go for iron also, we will go for the CS also. So right now we are dealing with the 2023 questions only. Then I will talk about 22, 21 like that. Okay guys. Alright, so that's all from this session. See you again. Till that, take care. Bye bye, bachcho.